Okay, so we're looking at some pH equations. For a strong acid, you can assume that the concentration of H plus equals the concentration of HA, because it completely dissociates. Therefore, the pH equals the minus log of the concentration of the acid, the HA. For a weak acid, though, you cannot assume this, that H plus equals HA, okay? It doesn't, okay? So we have to rub that out, okay? But we can assume that the initial concentration of HA equals the concentration of HA at equilibrium, because so little of it dissociates. So we have this equation here, okay? It's in equilibrium, it partially dissociates. So we can write the Ka expression which had H plus and the A minus on top. But because for every one of those make one of those, it becomes H plus squared, okay? We assume that the concentration of H plus and the ethanoate ion is the same, okay? To make that H plus squared. And then we've got the concentration there, which will be the same as it was initially. Rearrange that to get H plus, gives you that, and then you minus log that answer to get the pH. So the pH would be the minus log of the square root of Ka times the HA acid. Okay. For a strong base, we use Kw. Kw is the product of H plus times OH minus. So if you've got a strong base, NaOH, the concentration of NaOH will be the same as the concentration of OH minus. Sometimes be careful though, because it's like calcium hydroxide that has double the amount of OH minus, so you have to times it by 2 to work out the OH minus concentration. So we put these in here like this, rearranged to find H plus, that's Kw divided by the concentration of NaOH, and then you minus log that answer to get the pH. Kw is a constant, it's 1 times 10 to the minus 14 at room temperature. Okay, when we get on to weak acids and buffers then. So for weak acids we quite often use a pKa. The pKa is the minus log of the Ka. Okay? So if you want to work out what the Ka is, you can do 10 to the power of the minus pKa to work that out. Okay? If we put that into this expression here, we can rearrange to find H plus like so. Okay? And you do the minus log of that, that gives you the pH of a buffer. So the difference between a buffer and a weak acid is you have to work out the concentration of A minus. It's not the same as H plus because they do not equal each other. And there's another way of rearranging it to work out the pH of a buffer. So either of these are fine for working out the pH of a buffer. Okay, so here we've got a worked example, hopefully. Okay, am I in shot, cameraman? Yeah? Yep, okay. So we've got the concentration of a weak acid, we've got the concentration of the conjugate base with its salts, okay, and the Ka. So we're going to put all those bits and bobs in there, and we can just basically get down to the pH. It would be the minus log of the Ka times by HA over A minus, okay, and we're just putting those in there. So we get the pH of 5.07. So this is quite a simple example, but sometimes you have to work a bit harder to work out these concentrations here. That's what a good question gets you to do. Okay.